Now let's take a look at how to do a confidence interval for the difference of two independent means. So the two-sample confidence interval for two independent means is going to give us the range of values to estimate the true difference in the means of two independent groups, where that mean may lie. So the equation for the confidence interval is x bar 1 minus x bar 2. So our point estimate is the difference between these two values, plus and minus a t-crit, which is a t-score for alpha over 2, where alpha is 100 minus the confidence level. And then we multiply that by the standard deviation for the independent means. So that's the sample variance of group 1 over N1 plus the sample variance of group 2 over N2. And this follows a t-distribution with this big old formula for the degrees of freedom. So because we have this formula for the degrees of freedom, we are not going to do these calculations by hand. We are going to use technology to help us find, at the very minimum, the t-crit. Because we don't want to, well, really everything. To complete the confidence interval, there are two conditions that must be met. The samples must be independent, and the samples must individually satisfy the central limit theorem for means, so have a sample size of at least 30, or be drawn from a population that is known to be normal. When interpreting our confidence intervals, the interpretation is very similar to how we did this for proportions. So it starts off very similar to how we do our interpretation for means. We start by stating the confidence level, explaining the parameter being estimated, which is a difference in the population mean. We give context towards the problem, and then we give the range for the confidence interval, and we include the proper units. But then we add our second statement. And our second statement is based off of the sign on the interval. So if both values are positive, then the first group is larger than the second group. If both values are negative, then the second group is larger than the first group. And if the lower bound is negative and the upper bound is positive, then 0 is included in the interval. Therefore, there is a chance that there is no difference between the groups, because that would mean that x bar 1 minus x bar 2 could equal 0. So that would mean that they're the same and there's no difference. So let's take a look at an example. Suppose we want to test the mathematical aptitude of grade school children. We give two different classes the same math test and record the results. The first class, a third grade class of 30 students, has a mean score of 75 with a standard deviation of 3. The second class, a fifth grade class of 30 students, has a mean score of 84 with a standard deviation of 5 points. Construct a 95% confidence interval for the difference in mean test scores between the third and fifth graders. Now, this is a math aptitude test, so it's not necessarily looking at how much math do you know. It's just more of a how well do you learn math. So looking at these scores and thinking like, well, of course the fifth graders are going to score higher, that's not necessarily true because we're looking at just their aptitude for math, their attitudes, how well they can learn new things with math, things like that, but not necessarily just how much do you know so far. So let's look at the information that we got. So we have our first class, which is a third grade class. There were 30 students. They had a mean score of 75 with a standard deviation of 3. Our second class is a fifth grade class. They also have 30 students in their class. Their mean was 84, and their standard deviation was 5. Construct a 95% confidence interval for the difference in the mean test scores between the third and fifth grade classes. So we have X bar 1, S1, N1, X bar 2, S2, and N2. And then we also have our confidence level. So X bar 1 is the sample mean of the first class, which is the third grade class. So that's 75. Their standard deviation was 3, and there were 30 students. X bar 2 is the second class, the fifth grade class. Their mean was 84. Their S was 5, and their N was 30. And we are doing a 95% confidence interval. So what I'm going to do on this one is I'm actually going to just go straight into the website. The website is going to do all of the work for me. So I could go through and say, all right, I'm going to find the alpha over 2. I'm going to think about what I would plug into the t dot inverse to find the score, but I don't need to do that work. I'm not going to do that work because of the degrees of freedom. So I'm going to save myself some time and recognize that finding alpha is not really necessary because I'm not going to find the degrees of freedom. So I'm going to come up and I'm going to go straight into this website. And I'm going to go straight to my confidence interval calculator. So this is on the same page as the hypothesis test for the t-test and t-estimate for the difference of means. And I have a confidence interval calculator here. So my sample mean 1 is the sample mean for the third grade class, which was 75. Their standard deviation was 3, and their sample size was 30. The sample mean for the fifth graders was 84, with a standard deviation of 5 and a sample size of 30. And then the confidence level, we want to enter this as a percentage. We're doing a 95% confidence interval. So I'm going to calculate my confidence interval. So here we have the lower bound and the upper bound for my confidence interval, negative 11.14166 and negative 6.85834. And then we also see the answer for the margin of error. So this would have been the t-score times the standard deviation. It's great that it's there. I don't really need it right now. So I'm going to go ahead and come back up into my notes. And I'm going to write down my lower bound and my upper bound. So my lower bound is negative 11.14, and my upper bound is negative 6.86 when I round those. I could have gone to 1 decimal to give the accuracy to one more decimal than was presented, but I decided to go to 2 just because 2 looks better than 1 to me. I always like giving more decimals, not less. So that's the interval. That's it. It's done. All I have to do now is interpret it. So we are 95% confident that the mean difference in test scores between the third grade class and the fifth grade class is between negative 11.14 points and negative 6.86 points. This indicates that the fifth graders do better on math aptitude tests since the entire interval is negative. So on average, the fifth graders are scoring between 11 and 6, almost 7 points higher than the third graders. Somewhere between there. The fifth graders are doing better on the math aptitude test compared to the third graders. And that's how we perform the confidence interval for the difference of two means.